Okay. Hello, everyone. I think I'm going to get started. So my name is Jeremy Faucompré. I'm a technical designer and project manager at Neural Interactive, and I'm here to talk to you about Insurgency Sandstorm and some of the behind-the-scenes things for the development. So first of all, I'm going to tell you a little bit about Insurgency Sandstorm, for those who don't know the game. Insurgency Sandstorm is a hardcore, tactical, team-based, objective-oriented multiplayer first-person shooter. And that's a bit of a mouthful, but to give you a little bit of what all these means, essentially hardcore means that the game is very lethal. In many first-person shooters, it takes quite a few bullets to take someone down, and in our game, it's very quick. It takes 1 or 2 rounds. Tactical, because of the lethality, you have to play with your teammates, which leads into team-based. To be able to survive, you need to work as a team. And unlike other games, which is about racking kills and racking stats, et cetera, and about you as a player, this is more about the objectives that are spread across the map. You need to work as a team to capture objectives and defend objectives. And in some of our game modes, when you capture objectives, that's actually how you respawn your team. So it's very, that plays into the tactical aspect and has even a little bit of strategy to it. So we've been making this type of gameplay since the first Insurgency, and we've been getting, I think, good at it. This is now, I think, the 3rd iteration. And I'm going to talk to you a little bit about 3 aspects. The design and production processes. I'm going to give you an overview of that. But since this is Unreal Fest, I also wanted to talk about technical aspects, so the character customization cosmetics and the ballistic simulation features. So a little bit of personal background first. I've been a hobby game developer since 1996. I've been a mod developer since 2001, and I released my first mod in 2011. It's called Underhell, and then a follow-up, Chapter 1, in 2013. I got hired by New World soon after that, and shipped Insurgency soon after that, and I became project lead of Insurgency as post-release content went on. Then I relocated to Amsterdam to work at the on-site location of New World, and where I worked primarily as a game designer and level designer for Day of Infamy in 2016. And then when we started the project of Insurgency Sandstorm, I started as a project manager and technical designer from the get-go. So why talk about 3 separate things? That's a question that some people ask me, and I was also thinking, yeah, why don't I focus on one thing? And the reason behind that is that at New World, we kind of wear a lot of hats. Multiple people have multiple roles. That kind of comes with the indie development scene, but it also kind of comes with the fact that we started as a very small team. Back in 2013 when I joined, we only had 10 people, and everybody was remote. And the way we communicated, we just had one Skype group chat, and it was kind of a mess, and I'm kind of fond of those years. But yeah, whenever we had meetings, we would just do a Skype group call and talk. And there was no real design process. There was no production process. And we were kind of all modders on the team. We all come from a modding background. And obviously, because Insurgency actually started as a mod back in 2007, the founder of Neural Interactive, Jeremy Blum, alongside Andrew Spearin, the creative director, put together and worked over a very long time on the mod. And so that's our roots. And it's been who we are since the beginning. And now we're trying to shift our mentality to be a full-on indie developer with processes, et cetera. And Neural Interactive now looks like this. We have 35 people, 10 in Amsterdam, 8 in Denver, and 17 that are still remote all over the world. We do have now some structure, including design processes and production processes, which I'm going to talk about, but we still have a little bit of modding mentality. And what I mean by modding mentality is that mentality that anybody on the team can just add kind of whatever they want into the game. Before, it used to be more of that, where somebody would just kind of, oh, this is cool, I'm going to put it in the game. And they put it in the game. If it didn't break anything and everybody was OK with it, it would just go into the game. And now, and for the past year or so, we've been trying to step away from that. And what happens is when somebody has an idea, we talk about it, we scope it, we add it to the production pipeline. It's actually discussed by a lot more people before it actually gets into the game. And that's been challenging because the modding scene is very much, oh, what am I going to do today? Just do it. So I'm going to talk a little bit about how we face that. Since we've been moving on-site locations, we've actually started facing time zone challenges. I'm sure that some of you have this issue if your team is remote. We have very little time between the office hours of Denver and Amsterdam. And what happened is as we brought more and more freelancers who don't have work hours, who just kind of work whenever they want to, on location, we started realizing that we had less and less people working when we needed them to. So freelancers, they kind of like stay up when they want to. They manage their own hours, so they're always there whenever they feel like they need to. And at the time, we had most people in the American continent at some time, and the freelancers would try to, if they were in Europe, stay up late, and that was fine, that was great. But since we've been shifting more and more people on site, like I said, we've been realizing that we have less time to collaborate. At first, we thought, oh, this is cool. We're going to be able to work sort of 24/7. But in reality, it's a bit of a struggle when you have some people that just woke up and it's like, hey, let's have a meeting because I want to go home to go to sleep. And so what we did to try and offset that was to set the Amsterdam work hours later in the day. So I kind of start at 12 p.m., which is great. I don't complain about that. But at the same time, I also have some late meetings at time, and that's okay. Like, I can take those from home. So I get to sometimes leave early, go home, have dinner, and have a meeting. But yeah, so those are sort of the trade-offs that we get from time zone challenges. The bottom line is we needed processes because we were trying to be more formal and try to be more of a professional game developer. And so here comes the first part of my talk. I'm going to talk about design documentation a little bit, and design meetings, production management, and production meetings. This first part of the talk is going to be more of an overview. I'm not going to get too much into detail and all that, and then we're going to move on to the technical stuff. So for our design documentation tools, we started with Notepad. That's what a lot of people use, but a long time ago. And essentially, you would just put it on a Dropbox and put a Notepad, and there it is. It really quickly moved on to Google Drive, which is, I think, what most people use. And lately, we've been moving to Confluence, which is a tool that integrates with Jira, which is our production management tool, which I'll talk about in a little bit. The crucial thing, I think, for design documentation that has been crucial for us is inline comments. Inline comments is essentially when you select a part of a document, you highlight it, and you place a comment directly on that. And so what it allows to do is it allows to have specific conversation about a specific part of the document right there, and then people can kind of like a forum post, kind of like talk about it. And once whatever topic was raised, whatever question was asked is resolved, you can just resolve the comment, and it goes into the comments history, and then you can go back and read it. So inline comments have been crucial throughout the development. And to illustrate that, oh yeah, I wanted to say, the thing about inline comments is sometimes they even can cut meetings short or have meetings not happen at all, but I still want to say that meetings are important. You can't only rely on design documentation and design comments. And here's an example of a design document that we have. Here's the design documentation, and then we have a question there or a comment about it, and we can just see it there. And this is kind of like the process. And there's a lot of these, so it's really good to be able to have conversations about a specific point and not just people talking about separate things in the chat, and it's confusing. So this is great. A little bit about design meetings. So I wouldn't recommend that everybody should do this, but what we ended up having to do for Sandstorm, because we started production kind of high, like from Dev Infamy, we moved immediately into production. We needed to kind of catch up with the design, and we had 4-hour-long meetings pretty much every week. And the way we kind of did the meetings, we didn't formally set them from the get-go. We kind of just organically started adopting a process and a structure, and then we just kept doing that because it really worked for us. And what we would do is we would write documents during the week and review them during the meeting, discuss whatever design topics were brought on, kind of organize production for the week, and then write down the outreach that we need to do for certain people during that meeting. So it was kind of a design production meeting. Here's what the weekly design goals agenda kind of look like. So we decided to have it in one place so that we can scroll down and look at everything that we discussed. But essentially, we would have on the top the latest agenda on the very top of the document and write the date. And then as we discuss the topics, we just drag them through. And then as we discuss new topics and need to either talk more about it for the next week, we would add it back. If we had to do outreach with certain people, we would write it there, et cetera. And then using the inline comments that you can see, as you can see here, that allowed us to, before the meeting happened, actually maybe discuss some points in the meeting before the meeting is actually there. So every day throughout the week, I look at the design meeting agenda for next week, and somebody brought up a point. I'm like, actually, we don't need to talk about this in the meeting. It's very straightforward. Let me just put a comment and say, oh, actually, this is for this. OK, done, resolved. We don't have to talk about it. Cuts the meeting a little shorter. One thing that I can say we can do better would be meeting minutes. For those who are not familiar with what meeting minutes are, it's essentially a recap of what happened during the meeting. So essentially what was discussed and what the decision was made, why was the decision made, and who made the decision so that people can direct their questions to them. We didn't do that exactly as concisely as meeting minutes should be. We kind of did, at some point, kind of an internal blog post where Michael Tsuru, as the lead game designer, would kind of write in a pretty way very fleshed out way what we discussed, why it was meant that way, to try and get the team on board. And that worked. It gets the team on board. But the thing is, since we had those design meetings every week, and he would spend like a day or two working on them because there was more questions were brought on, it ended up taking a long time for him to work on those. And similarly for me, I would kind of do production recaps every week. Oh, here's what we worked on last week, and here's a bunch of screenshots. And that would take quite some time to put together. So in the end, we just stopped doing those, and we even forgot to do the meeting minutes. And sometimes we would talk about a design thing, and then the next day somebody would ask a question that we already discussed because they didn't really have the design information right then and there. So meeting minutes are good, and we can do better at those. And we kind of put all those things into our design documentation. So now I can move on to production management a little bit, and I'm going to talk about our production management tool, or project management tools. Again, Notepad. The very first thing I used, even when I was a modder, I would just have a bunch of Notepad documents, and I would make them pretty with like ASCII code, like little equal signs and little slashes, and here's this, here's that. Really quickly, though, we moved on to Trello, actually, at first, because it's very visual. I think a lot of people use Trello. Trello is pretty. Trello is great. And what ended up happening, though, is that we couldn't get super into detail or add very specific deadlines or have multiple people work on a specific task. And so move on to Jira, even though at first Jira was intimidating, especially as a modder. The first time I was like, hey, can you use this as a project management tool? I was like scared because it's very professional. But as I started using it and I started kind of researching it and sort of evangelizing it to the team, we started adopting it, and it's actually worked really well for us. And one thing I want to bring up, sprints. So this is Scrum mentality or an agile mentality in project management, but essentially sprints are a short period of time in which a set amount of tasks are being worked on. It's just a little bit of terminology because I'm going to be talking about sprints a little bit. We also use Google Drive for project management, but only high level. So usually before we set out tasks, the producers and designers, we kind of get into a document and write up, okay, here's what we're going to work on a very free-form document together. And that's where it starts. And then lately, we've been using Confluence, which integrates with Jira, which is pretty nice. And it's kind of our wiki now that we're trying to populate more and more because everything is kind of connected there. And that's really nice. So the way we set up our Jira sprints, we use 2-week sprints to kind of keep them short enough. But whenever we're pushing deadlines, we can also use weekly sprints. So if we have a deadline coming up, we just say, OK, we're going to focus week per week. This is what we're working on. As for task estimations, we use story points. Story points are essentially a measurement method to estimate how big a task is. It's used through a lot of project management tool. And the thing is, you kind of set what the story point means for you. So at first, the first, I think, iteration we did was one story point is 30 minutes of work. And that didn't really work because people are bad at estimating how long it takes to do something. So then we tried one story point is 1 hour, it's 1-to-1, it's great. But that didn't work out either because people are really bad at estimating how long something takes to make. And lately, we kind of settled on 10 story points is 1 day of work. And that seems to work. Actually, people are pretty OK at telling you, you know what, this is going to take more than a day, less than a day. Like a day is like a chunk of time that's big enough for people to estimate accurately. And another thing is, since it's divisible by 10, then if it's half a day, it's 5. If it's 2 days, it's 2, etc. And since there's 5 work days in a week, if I look at somebody's task list and I see that they have more than 50 story points, I'm like, OK, this person has too much. I'm not going to give them any more work. And then I can get a feel, we can all get a feel for how much work anybody has. What it looks like is, it looks like this. So we have the sprint board with everybody, the task, the description. And on the right there, we got the story points. And we can kind of see how much everybody has. For instance, over here, we have Victor, who has 50 and then 25. And I kind of know that that's a lot. But remember, those are 2-week sprints. So it's actually the total is 100 for 2-week sprints. And yeah, this has worked really well. We've been adopting it more and more and getting everybody to use it more and more. At first, it's difficult to get modders to try to adopt this. But now it's almost second nature at this point. And it's great. In terms of production meetings, we've been having sprint meetings that kind of come with a package once you start working with Scrum and Agile mentality. And the thing that we've realized with meetings is we didn't know when do you have the meeting. At the start of the sprint, the middle of the sprint, the end of the sprint, where's the best place? And the truth is, it kind of all worked. At the start of the sprint was great to prepare the meeting and the tasks ahead. In the middle of the sprint was also great because we can see what we actually accomplished in the week that just happened and what is left to accomplish. Are we on track? Do we need to rescope? And at the end of the sprint, it was great to reflect to see what went wrong and prepare the sprint ahead. So they're all good. The point is have meetings, have conversations about production. Don't skip them. And one thing is, when we did have those meetings, we kind of had full team meetings, so we had as many people on the team present in the meetings. And that's great. We get to all hear our voices, which is actually rare, and I'll discuss. But it caused an issue because when the programmer is talking about programming stuff, the artist doesn't really care. The character artist is just like, just tune it out. Don't listen. And so one thing that I think a lot of people do is department meetings. Those are great, but the thing is they're very formal, and we're trying to move there, but we haven't started doing them yet. And what we do right now is kind of free-form meetings, where we talk about the task, we set them, and then before we actually create the task, we approach the person that's going to be assigned to the task, and we have a conversation with them about the task. And is this okay? Is 10 story points, 1 day work, is that enough? We have a little conversation, and then once we agree with the person, we create the task, then it's there, then we can leave comments, etc. And that's working really well. So we kind of do individual meetings for production instead of department meetings, and we're trying to formalize those meetings, but we haven't done that yet because it's difficult sometimes to grab people and say, hey, let's all meet up every week and to talk about things. It's important, but they're all working, so. So that was an overview of design and production. To recap, we create design documentation during the work week. We comment and iterate during the week. And for the things that we need to actually discuss, we have design meetings every week. Ours were 4 hours long. Yours don't have to be. Hopefully they won't be. We reach a consensus on the documentation, and we plan the week ahead. And during the week, we execute the plan, create new design documents, and prepare the upcoming design agenda with whatever is brought up during the week. And then production meetings, hopefully by department. If not, individual, free form is fine. And we bring up issues and rescope if it's necessary. So now we can move on to the technical stuff and get into Unreal Engine a little bit. I'm going to talk about the cosmetic system for Insurgency Sandstorm. We have a lot of cosmetics in the game, and let's look at them. What it looks like in the game is it looks like this. You go in your appearance menu, and you equip your character with a bunch of stuff. Here you're equipping the Kevlar helmet, PASGT helmet, and you have a bunch of colors, etc. So first, I want to give a shout out to a few people. Adam Sikora for designing and implementing the backend side of the system. Steven Swires for designing and implementing the cosmetic and variation blueprint asset. Michael Tsarouhas, the lead game designer, for designing the cosmetic and variation relationships. Nick Somnall for rigging all the cosmetic meshes and setting up the cosmetic logic and some of the variation logic. Gabriel Franza and Ramiro Guzman, who did most of the character arts. Those guys are awesome character artists. Fox 2D for an outsourcing company for providing some of the additional character art when time was short. And Robbie Marcus and John Mabroom for implementing the recent scalable mesh merging, which I won't go too much into detail because that's very technical, but it's important for optimization. An overview of the cosmetic system, we essentially have 2 assets, the cosmetic asset and the variation asset, and they have a bunch of stuff in it that we're going to look into one by one. On the cosmetic asset, first, on the collectible side, people need to be able to unlock their cosmetics. So as players play the game, they get XP from playing, they level up, and every time they reach a new level, they get some credits, in-game credits, that they can then spend on cosmetics and unlock, or they also get a random cosmetic drop. So every single cosmetic/variation needed to have a unique ID number so that we could identify them in the backend and in the game, etc. They'll have a rarity, which is how rarely they drop into the game every time you level up, how rarely you get them, and a cost for the credit cost, and they're faction specific. So like I said, we needed unique IDs for everything, and we didn't know how many cosmetics we were going to have from the get-go, so we kind of needed a system to be very flexible and to be able to have sort of infinite cosmetics if we want to. And so the system we came up with was, and actually Adam came up with the system, is variation IDs go from 0 to 999, and those are shared by all the cosmetics. And the cosmetic IDs are every 1,000. And so if you add up the cosmetic ID and the variation ID, you get a unique cosmetic/variation. And what this looks like in practice is you have the cosmetic ID on the left, the variation ID on the right. And as a practical example, what it looks like. You have the glove, which is 300,000, and then the variation is 101 is white, 107 is red. And so with just a unique number, everything is already allocated. So we don't need to know how many we're going to have. We can just keep adding numbers, and they will just work. A quick note about the variations. We didn't want players to be able to pick whichever color they wanted. We wanted to sort of author colors and use them and give them to players for selection. And we wanted to keep the colors very distinct for the team. So this is something that Michael Tsarouhas and Gabriel Franza worked on quite a bit. So we wanted to have very earthy colors for the security faction and very kind of brand colors, civilian clothing colors, flashy colors for the insurgents. And this is important because those sort of assignments, so in insurgents, for instance, we have 1, 2, 3, etc. And so I1, I2, I3 is how we name the colors because we wanted to keep the flexibility of changing the colors without having to change the name of the color. You'll see what this looks like in a little bit. Here's what our spreadsheet looks like for all this. It was a lot of fun. But essentially, you have the name of the asset, the ID, a bunch of settings, the variation, and it's great because I can just add new ones in between and just add a number that's not used yet, and it's easy to keep track of. So we reserve cosmetic IDs by slots for the future, and we try to allocate around 50 ideas per slot. So we have 50 gloves, 50 pants, etc., and we just jump 50,000 every time to then work on the next slot. So every slot has about 50 cosmetics reserved for them. As for variations, because they're shared by all the cosmetics, insurgents have 499, or 500 if you include 0, and the security has also 500. When it comes to the rarity, they're set per cosmetic, and those are pretty generic. You have on by all, which is everybody gets it, and then there's common, uncommon, rare, very rare, and exotic. And then we have a few special ones. Unavailable is when the stuff is made and it's in the game, but we don't want people to unlock it yet, so we don't want to release it yet. We just set it to unavailable. And then there's pre-order for people who pre-order the game, and developer, which is just for us. But we don't have any of those yet. And what this looks like in the game, same screenshot as before, on the corner here, we have a little color, and this is essentially the rarity of the item. So white is white is common, green is uncommon, blue is rare, we have purple for very rare, etc. And that's kind of what you see. And the cost of the cosmetic is actually dependent on the rarity. We try to base the costs to make sense. So common items are cheaper, uncommon is a little more expensive, etc. When it comes to the cost, like I said, we base it on the rarity, but we also have an override for certain colors that we think are really cool, like black or colorful items, because black is cool. So if we look at the beanie, we have all the colors that are 200, but black is 400, and it has a little yellow thing in the corner there, because black is cool, and we don't want everybody's just going to be black, wearing black because it's the coolest thing. So we try to price it a little higher so that people actually get the other things first. If you look at the blueprint, what it looks like is actually not a whole lot. It's everything I talked about. There's the faction restriction on top, the gender, the slot, the name, the rarity, the item, whether the boss can equip it, the UI name, and then all the variations. It's all there. And the great thing about this is any designer, anybody who doesn't necessarily have Unreal knowledge can just look at this and figure it out and change it. And that was really important for us to not have to bother a programmer every time we want to change something. As soon as the system, the basic system was in, we could just add as many as we wanted, and we did. So about slots, they can be faction specific, and they can contain subslots, and I'm going to show you what this looks like. So for the security team, we have a gender swap that's specific to the security team, and then we have a character subslot, which we'll get into in a second. And then the camo slot is also just for the security because only the security can wear camo. That was a decision that we made to, like I said, have the teams be immediately identifiable. If we go in the character subslot, we have the head that can be changed, which is affected by the gender. So if you change your gender, you can have different set of heads. Same for the hair, same for facial hair. Hair color, which affects both hair and facial hair, because we didn't want people to have like gray hair and red beard. Like you can have a dark red beard if you want, but it will just affect your whole hair. And then tattoos, which are also faction specific. And I'll show you tattoos in a little bit. But essentially, each faction has kind of thematic tattoos based on their faction. And then the voice is affected by gender as well. So if we look at the insurgents, we'll see that the slots are a little different. The insurgents don't have headgear. They have faceware, which is always equipped. So you can't actually see the face of your insurgent. That's a thematic choice, an art choice that we made. But it was also a production choice because then we have less heads to make, right? So you're always wearing something, and you can change whatever that is. So we have shemags, we have balaclavas, and we recently added bone-face balaclavas, which is a balaclava with a skull face on it. It looks cool. I'm sure everybody is wearing that. If we get into the character subslot, here we have the eye color, which we can change, which is very subtle, but it's nice. The skin tone, which is the skin tone, and then the left arm tattoo and right arm tattoo, which are also faction specific, which is, they're different. So if we look at the tattoos real quick, first of all, we wanted the tattoos to be something that you can see on yourself, and so the only place on the body for a first-person shooter that is the case is the forearm. So we only have forearm tattoos, and you can actually see them when you're holding the weapon. They're on your arm, It's cool. And another thing to note is that in order for you to see the tattoo, you need to unlock the cosmetic that has short sleeves. I think the Insurgents by default have a t-shirt as a default cosmetic, but the security team actually has a long sleeve blouse. And so in order for you to see the tattoo, you need to unlock the rolled sleeve blouse and then the tattoo. And it's kind of like a little layered cosmetic thing. Like if you want your character to look exactly that way, you have to unlock a few things, and that's fun. That's player retention, it's progression, and it's customizable. The cool thing about this from the get-go is that it's flexible for more. We can keep adding as many cosmetics as we want, and the system is already there for it. And in the future, if we want to add new type of customization, we can just add a digit on all the way to the left, and then we have millions of numbers. And then we can have new types of cosmetics. So for instance, weapons could be a thing that we do. I don't know yet. And then doing that would give us a new set of variations that would be unique to that new cosmetic types. And that's the cool thing about numbers. They're infinite. So there is a lot of flexibility there. Then let's get into the cosmetics themselves. So we have the meshes. We have the first-person mesh, the third-person mesh, and the sub-model that we, at the moment, only use for the arms. So when you set a head for your character, it changes the actual arms of the character. So you can set a female head, and then you have female arms, etc. Here's some of the meshes that we have. We have a lot. We use the modular character building system to do that. So we have torsos, and here's the corresponding first-person models. We have pants, shoes, bunch of heads over there. That's a little creepy. But it's a lot of it is there. It's not all there, but there's actually more off to the sides and items and gears. But yeah, it was a lot. And it was a lot of work to get all that in. One other thing that I need to bring up is morph targets. Morph targets is a snapshot of Virtue's location for a specific it basically allows you to deform the mesh. It's really cool, and it's very necessary. If you have a lot of different character with different head types and different things, it's important to be able to morph whatever the cosmetic is to the character. And to show you a quick example of that, here's a hair bun. And then when you put a little baseball cap on it, it pushes the hair bun down. And we actually have different morph targets per hairstyle, per hair bun. And that's what I'm going to talk about is we have a lot of dependencies for the morph targets. So the head changes the hair, the headgear changes the face wear, which changes the hair, the eyewear changes the head. It's a lot. And I'm going to show you some of these. But essentially, here's the hair. Here's a beanie with the hair, which pushes like the little bun down. Here's the glasses with the hair, which pushes the little beanie up a little bit. Here's a helmet, which pushes the hair differently. And then here's the glasses that pushes the helmet up. And it's a lot. So lessons learned about morph targets, try to plan them ahead if you can. The truth is, as different artists are working on different things, it can be difficult. So we have this 5 GB character file where everything is in, so character artists can kind of see the morphs and see what they need. But even then, we have a lot of QA reports every day. Hey, this is clipping. Hey, this is weird. Hey, this girl has a beard. So we try to fix all that. And try to have as many reusable morphs as you can. This is actually a system that Nick Samal came up. He realized that some of the morphs between characters could actually be interchangeable. And so instead of having unique morphs for everything, he came up with a crazy name, which was like, I think it was the idea of the head underscore the idea of another head, underscore the idea of another head, and that way we can kind of reuse the morphs. And the reason why we do that is because morphs are extremely expensive. The more vertices you move, it needs to be saved in the mesh as like mesh information, and then it has the LODs for that. So every time we add morphs, we actually make the mesh more expensive, which is expensive to load, expensive to change, expensive to morph. So yeah, we're looking at optimizing that right now, but it's a lesson learned. Plan ahead for that. Now let's talk about the variation asset. The variation is essentially the color or the texture or material that you assign to the cosmetic asset, so to the mesh. We have 4 of those. We have a color combination, which combines 2 colors, a pattern, which uses the color combination and as a pattern, and then the camo, which is a set texture and color accents. So what this looks like is you have a track bands, and hopefully with the system we can change the color. So the track bands, here's a track band texture, which is the red channel is the color, and the green channel is the dirt layer, and so it kind of looks like that. And then when you separate all that, you kind of get to see it. And then you have the ID mask, which we use to actually determine which colors goes into which channel. And so you'll get it in a second. But essentially what it looks like is it looks like this. The base texture has red, which is the best color. The darker the texture, the less color it receives. Then green is the dirt layer, which we can change separately. And we don't actually use the blue channel, so we're reserving that for the future, maybe for scratches, maybe for other type of texture information. Then on the ID mask texture, we have 5 separate things that we can set. It's RGBA, so red, green, blue, alpha, but we actually also use the black of the texture. So if there's no information there, that's also information that we can use. And so it's maskless, layer 1, layer 2, layer 3, layer 4. We try not to use the alpha channel of the ID mask if we can, because adding an alpha channel, as you may know, doubles the texture memory size. So we try really not to use it unless we really need to. What the shader looks like is this. It may look complicated, but the truth is it's actually not. It's the same thing done over. You have the maskless, the first layer, the second, the third, the fourth, and then a material function that Robin and Christian worked on, the shader programmers, and then you just blend everything together. So although it may look complicated, it's actually not that complicated. It's just a lot of the same. Even I'm a designer, and I can kind of read through this and get it, and if I need to change something or ask a question, I actually know where to ask the question. So it's cool. What it looks like in the material editor is you have the material, the texture, and then if you see on the right the vector parameters, you can just change them, and it just changes the color of the elements that you want based on the ID mask on the top. So we can have any color that we want. So our pretty track pens from before, they can be red, they can be any color, and you can have different elements of the material have different colors. That's the whole point of this. So how do we do this? We use the dynamic material instance node from Unreal Engine. What it does is it grabs the material, it creates a dynamic material instance on the fly, and then we set the vector parameter values for each of these color parameters. If we look at the blueprint, it looks like this. It's very simple, actually. We just have a valid check, get the material, create the node, and then loop 5 times for the 5 channels that we talked about. And you just apply the vector parameter that we have set in the variation asset. It's 1, 2, 3, 4. It's not a whole lot. If you open the color struct, those are the material parameters that I talked about earlier. It's color, layer 1, layer 2, layer 3, layer 4. And it just sets them on the right color. And what it does is it works. You have a red shirt, it just changes into a blue shirt just by changing the supported variation. And it's pretty straightforward. Now moving on to the next one is color combination. It inherits the color system. And the reason we did that is because we didn't want to have to create unique colors for everything, so we kind of did it procedurally. And what I mean is we have the color assets, and then with the color combination, we grab 2 of those and populate that into whatever has 2 colors. We did it for the sneakers, for the track bands, the track top, and a few other things. What it looks like is it looks like this. You have the primary color variation asset, which is just a color, and the secondary, and then there's a channel map that allows us to remap, essentially, which color to use from which asset. And the names that you see there, the color I1, color I4, is what I talked about earlier. So I1 stands for Insurgent 1, and I4 is Insurgent 4. So I1, I4 is white and black, essentially. And it's the same for the security. If we have S1, S8, it's actually sand and foliage green. I hope that's the right tone of green. But yeah, if you open the blueprint, what it looks like, it's, again, because it builds on the already existing system, it's pretty simple. You just get the variation asset, and you remap the color. And then for the second one, you remap the color, but you take into account the channel map so that we can change which channel we want the color to be remapped on. And it works, and it's cool. You can have orange-white sneakers. You can have red-black sneakers, any color combination that we authored. And that's the thing. We didn't want players to be able to, like I said, open a color gradient and just set whatever colors they wanted. We wanted to author the colors. And here they are. And they reuse the original colors. So now if we go back in the previous colors and decide to change the orange tone, it actually reproduces it everywhere, procedurally applies it to everything. More examples, track bands, track top, a lot of things. Next up, the pattern system. It inherits the color combination system, so everything is kind of built up of each other, and it contains 2 pattern textures. And then the only new thing that this does is it sets the texture parameter value on the dynamic material instance. So it replaces a texture on the fly. What it looks like in the blueprint is this. Like on the bottom is the color combination that we talked about already, and it just has 2 textures on the top and rescaling for the pattern if needed. And the blueprint asset looks like this. There's a valid check, creates the material instance, it gets that, and then it applies the texture, and then rescales the texture if need be, and then it applies the color combination. It's built off the previous system. And what we get is we get these cool shemags with different patterns, different colors, and we can just plug new textures every time we come up with a new pattern. We just plug it into the system, and it just populates it on everything. And we use it for quite a few things that have different patterns, like camo T-shirts, some type of camo T-shirts, but only for the insurgents. The camo system, which is separate from the camo pattern, just has a big color into it, and it inherits the color system and only contains the camo texture. And it kind of works like the pattern system, but it's different in the sense that you can't change the color of the camos. You just change the color of the accents. You'll see what I mean. The blueprint looks like this. It has the texture and then the accents that we set manually. And inside the blueprint, it's very similar to the pattern system. It just grabs the texture, applies it to the variation, and then sets the scale. And what it looks like in the game is it looks like this. You have the cool camo with the bait colors. So those colors in the camo, they're actually in the texture itself. We don't have, it doesn't use the color system because we want it to have more than 2, more than 3. We want it to be able to have as many as we wanted. So the color of the camo system is for the accents. So like the knee pads here, or this here, or the t-shirt, all the little bits of the camo that are not camo, that are accents, that's what it's used for. And those are actually authored. So per camo, our artist kind of goes in and says, OK, this accent looks like this accent looks like that, and it's more unique, and that's cool. And we have a lot of camos, and every time we add new ones, it just works wonderfully. So to recap, we have the Cosmetic System, which has the collectible, the cost, the rarity, the meshes, and then the supported variation per the cosmetic. It's great. It's just 2 assets with all the settings, and we can add as many as we want without bothering a programmer. The latest thing that we are adding and working on is the scalar mesh merging. Essentially, when a character is wearing all those cosmetic meshes, it's a lot of scalar mesh components on the character, and we have to update those every frame, which is expensive. So scalar mesh merge essentially allows us to grab all those things once they're loaded and put it into a single mesh. It actually is taking a lot of work to get this to work because we need to take into account morph targets. We need to make sure that it's loaded. What happens if a new player comes in the middle of the play? Do we reload everything? So it's a bit of a headache to get it working, but it's a good optimization. Moving on to the third part of the talk, I'm going to talk a little bit about the Ballistic System. I'd like to give a shout out to Steven Swires for designing and developing the Ballistic System, and Robin Marcus for helping out the Ballistic spreadsheet and some of the math there. He wrote a custom script for it that I'm going to talk about. Quick overview of the Ballistic System. We have the weapon, the ammo type, the velocity deceleration, pre-simulated for simulated. I'm going to get into all these one by one. One note, though, is our characters' HP is 100, so their health overall is 100, which is easy to remember and easy to divide. If we look at the weapon, there's only the muzzle velocity, which is the velocity at which the bullet leaves the gun, and the ammo container, and that's it. That's all the weapon. In terms of ballistics, that's all the weapon does. The weapon has a lot of options for recoil and a lot of other settings, which is another talk. But in terms of ballistics, that's all the weapon does. And if we look at my beloved spreadsheet, which Robin held for the math, here's all the ammo types. Here's all the basic muzzle velocities that we actually reference from real life. We try to have this as a realistic starting point. And then everything else, we author it to make it gameplay, to design it ourselves. And so here are all the values, and there's all the settings that we have in the game. We put them in the spreadsheet, and allows us at a glance to see what's happening without having to test every time. Here's the muzzle velocities. If we look into the ammo type, that's where all the magic is done. And essentially, it contains a lot of curves and some options. Damage by current velocity curve essentially maps the damage that it does to the player when the bullet hits you, mapped by the current velocity. So how quickly the bullet is going is how much damage you'll receive. Penetration power by current velocity is the same thing for penetration. Velocity deceleration is the same thing for decelerating. So how quickly the bullet decelerates is based on how quickly the bullet is going. And then we have some options that we use for different things like spread modifier for shotgun, tracer particles, etc. But that's just other things. If we look at what the blueprint looks like, and this is the cool part, this is where designers like me or Mikey can come in and just change things, is it's all very visual. So we can just input the numbers and change things, and we can completely change how any gun is handled in the game without having to do any code. We just come in and change the numbers and change them in the spreadsheet, and then we can see kind of what it does, and it helps us. And so if you look at all those curves, you may notice that they're all flat. There's no curves. So where are the curves? Because bullets can occur over a distance. So let's take a look at it. The magic happens in the deceleration of the bullet. Essentially, the way it's handled is deceleration by centimeters, which is very small. So we're going to divide it by 100 to get it to meters per second. So it decelerates in meters. So when it's traveling at 1,000 meters per second, the bullet is decelerating at 1,500 meters per second. And then you think, wait, doesn't that mean that in 1 second it will go like back because it's decelerating more than it's accelerating? But the thing is, that deceleration also decreases as the bullet is decelerating. So it's a little hard to imagine, but essentially what this does is this creates a natural curve because it's decelerating really quickly and then less and then less and then less, and then it curves down, and that's where the curve is. It's not actually visible in the blueprint, and the reason why we did that is because it's easier to predict. Like linear curves allows me to just plug this value in the spreadsheet and this value in the spreadsheet, the top and the bottom, and then the spreadsheet calculates it linearly, but the curve is actually still there. When you fire the bullet, it will decelerate naturally in the distance. And there's the curve, and it's pretty nice. And that's what bullets do. They fall and curve. So in order to put this in the spreadsheet, we actually had to code a script in the spreadsheet because it happens, there's a sub-step for it, and Robin, one of the programmers, helped me out. And here's the thing. He just copied it from the game code into Google Sheets and just had a little function there. And essentially, we have this nice little thing now that's called velocity at distance. And it just tells me how quickly the bullet is going at which distance, which allows me to then check a bunch of things. And it's like, OK, how much damage is this doing to armor, to no armor, to heavy armor, et cetera. So great for design. So let's talk a little bit about simulation, the bullet simulation. Essentially, the bullet, before it's actually simulated, there's what we call the pre-simulation, which means that for the first 0.1 second, the bullet is traveling instantly. There is no trying simulation. It just, as soon as you fire the trigger, it just clicks. And this is meant to mimic the hit scan system. If you're not familiar with the hit scan system, it's from the dawn of first-person shooters. Essentially, wherever your weapon is pointing, when you click, it just does trace immediately, and if there's anything in the path, it just shoots that. There's been a little bit of misunderstanding as we were developing Insurgency Sandstorm. We said that we had a hybrid system for bullets, but it's a pre-simulation system, which means for the first 0.1 second, the bullet happens instantly. And this feels more gratifying because it happens in one frame. It doesn't actually, like, if you're lagging a little bit, it doesn't matter. It just happens instant. One thing to note is because it's pre-simulated over using hit scan, we still get bullet drop, even though it's negligible. Like even though it's 0.1, the bullet doesn't really start dropping yet, it's still taken into account, so it's very accurate. After that 0.1 second, then the bullet is actually simulated. And if we look back at the screenshot that I had earlier, these little square there in the debug allow us to see where the bullet starts getting simulated. So you can't see where it's coming from, but essentially you fire a bunch and you see little squares like, OK, this is where the simulation actually starts. And then if I were to hit play here, this is a screenshot, but if I were to hit play in the distance, you would actually see the bullet still falling very slowly. They actually, and it's cool. Here are the curves. They're still there. For the bullet penetration, the way it works is it works per surface types. So all it does is it has an impact speed loss. So as the bullet impacts the surface, it loses speed. And then there's speed loss by penetration power per unit, which is a mouthful. But it's essentially based on the penetration power of the bullet, how much speed it loses per centimeter inside the surface. And those are the two values. A quick overview of the surface system in Unreal Engine, for those who don't know. In Unreal Engine, in the engine settings, there's surface types, which are kind of like parents. And then there's physical materials, which you set to the surface type. And what we actually did is there's an option in the physical material called density multiplier, which is used for weight, actually, for physics. But we actually tied that to the penetration system. We're like, the more dense something is, the more resistant it's going to be to penetration. So if you have a metal that's 1 density, it will penetrate less than if you have a metal that has, well, you'll penetrate more than if you have a metal that has 5 density, and it will also be heavier. So we tied the penetration kind of resistance to the density of the physical material. Here's an overview of our physical material / surface types in Sandstorm. So essentially, the one on the left is the surface type, and the ones underneath that are the physical material. And we have a lot of them. And the reason why we have a lot of them is because they each have a unique sound. And our audio designer, Mark Winter, had a lot of fun with that. And essentially, it all sounds a little different. If you hit a metal bottle, it will metal barrel, it will sound different than if you hit a metal sheet. They all have slightly different properties, too. Metal sheet penetrates more than metal, et cetera. And some of them have a unique decal and just a bunch of other settings. Here's what my debug map looks like. I spent a lot of time in this, shooting through a lot of stuff. Here are all the physical materials layered into 10 centimeters, 20 centimeters, 30, and then 40, which 40 is our basic walls that we use in most of our modular level design tools. And if you look and start shooting through them, you will notice that through wood, it just goes through 1, 2, 3, and then apparently there's like a bullet that actually went through. It happens sometimes, and there's a nice curve there, so that's nice. But if you shoot through metal, it just goes to the first one, and then it stops because it's metal. It's what it does. It stops bullets. If you shoot through foliage, it will actually go through pretty much everything. Foliage, we use foliage for grass, leaves, and other things like that, and essentially has the lowest penetration that you can have. And the white one on the left, that's not foliage, that's snow. We don't have snow yet. Maybe we will have snow. But essentially, yes, if bullets go through snow, if you have a snowman mesh that has a snow sent to it and you shoot through it, it should go through. So, yeah. Last bit about the surface type system, there's ricochets. We actually have ricochets. Some people playing the game might not know that, but our bullets actually ricochets against certain surfaces. And it's pretty simple. It's just, can the bullet ricochet against the surface? And what is the minimum dot product, or the angle that the bullet needs to hit the surface in order to ricochet? And what it looks like in the blueprint asset is like this. You have the penetration, impact speed loss by penetration power, and impact speed loss inside the surface, and then can it ricochet, yes or no, and the minimum dot product. And we just have all the surface types there, which are not that many. There's a lot of physical materials, but there's few surface types. And essentially, I think we only have ricochet enabled for concrete, metal, ceramic, just the ones where the bullets would actually not go in, like tighter, denser materials, more solid materials. So what happens if you shoot at a certain angle on a car or anything, the bullet will actually bounce back. And it actually even happened here on the left. That was not intentional. I was trying to get it to ricochet on the car, but it actually happened on the left. And you can see there's all the little curves back there. And you can actually see the pre-simulation, like the purple squares starting. So that's where it actually starts pre-simulating. So when it ricochets, then it simulates, but then it didn't start simulating until there. So all the features I talked about are kind of visualized here. And it's great. It has a lot of chaos into the scene. Sometimes when you have people firing corridors, the bullets kind of just go everywhere. It's pretty cool. The last bit of gameplay related to bullets is armor. It works similarly to the bullet penetration per surface, but it's something that the character is actually carrying. And all it has is velocity modifier by penetration power. And what this means is the bullet hits the armor based on the penetration power of the round at a current velocity, it will slow down the round. And then on that new speed of the round, it will damage the player based on that new speed. Just like real armor kind of slows down round, and then you get hurt based on how quickly it went through you. If you look at the character, those are her hitboxes, and the hitboxes are affected by the armor, all the chest ones, stomach ones, and the groin, which is only there for heavy armor. So if you look back at the screenshot before, you can notice that the heavy armor, which is on the left and the left here, they have a nice little ground plate, which is more protection. And yeah, that's what the ground plate is. So it actually protects the players there. Then the way we designed that with all the previous ballistic systems, we have a nice little spreadsheet with Mr. Healthy that, courtesy of our lead game designer, Michael Tsuras, he put this together, and then I plugged all the values in the spreadsheet. One thing to note is that depending on the hitbox that has hit the bone, you take more or less damage with a damage modifier. So the head is multiplied by 5, because all headshots will kill you, always. Neck is 2.5. You can see all the values here. And what happens is all these values are taken from the previous spreadsheet, and it just inputs all the data here. I can just have it drop down with the gun and the distance modifier, so like what is the distance that my bullet is being received, and then the damage for armor, heavy armor, etc. And then I even have a little number that's bold that's like how many shots does it take to kill that player from shooting it there. So it's probably 5 shots to the foot. I don't really design things for shooting to the foot, but it's important when it comes to the center of mass and the head. You always want to make sure that the game remains lethal, and it was a godsend to be able to have all this and be able to design visually without having to test. I remember sometimes we went in the game and shot at a bunch of dudes to see how quickly they would die. And so the spreadsheet kind of allows us to pre-visualize all that from the get-go. And so to recap, the weapon only contains the muzzle velocity and the ammo container. The ammo type is where the magic happens with all the curves that look flat, but they're actually there. Then we have the bullet penetration and ricochets, which is where all the magic happens when it comes to penetration. And then we have the armor, that kind of works like the bullet penetration, but is for the gameplay asset. And that's the technical stuff. So to wrap up, in regards to design and production, we learned a lot throughout the development of Sandstorm. We created new processes, new workflows, and we'll continue to do that. And I'm got to say that all the blueprint system from Unreal Engine allowed designers to do technical things without having to bother technical people. And it kind of allowed me as a designer to even become a little bit technical, because I was able to just visualize all these things and even come up with systems without having to really bother anyone who was doing more important things. And so as soon as the basic blueprint system was in place, I was able to create all the bullets and all the ammo types, etc., or at least to tweak them. I don't think I created all of them. And same for the variation. As soon as the cosmetic and variation asset was there, it was great. And so, yeah, that's my talk. And enjoy the rest of the Unreal Fest.